There are many ways to describe how big a cake is. Diameter, height, circumference, mass. But the most useful measure is number of people it serves. So all cake manufacturers now use this on their boxes. Everyone has seemed to agree to use these as units for cake size. Another example is length. There are many ways to describe length. In kilometers, perhaps a long journey. Or in meters, perhaps the height of a bridge under which vehicles pass. Or in millimeters, perhaps the diameter of a drill bit. Or in centimeters, perhaps the length of a piece of paper. All this is fine, but in physics calculations, we must only use meters, m. Now, if you have been given a length that is not in meters, you need to convert it. So to deal with a number of kilometers, replace the kilo bit with times 10 to the power 3. To deal with a number of centimeters, replace the centi bit with times 10 to the power negative 2. And to deal with a number of millimeters, replace the milli bit with times 10 to the power negative 3. Here are some examples. So for the first one, notice that the 5 stays the same, the meters stay the same. It's just the centi bit that gets swapped out with times 10 to the power negative 2. And with the others, again, we switch out milli for times 10 to the power negative 3 and kilo for times 10 to the power 3. Similarly, we measure force in newtons, N, but also in many other ways. For example, we might see giganewtons, kilonewtons, or meganewtons when talking about jet engines, or you really strong physics students pushing massive rocks around. But in physics calculations, we must only use plain old newtons. And it's the same for all other quantities. Those first parts, like kilo and all the rest, are known as prefixes and need removing. How do we convert? Well, again, we just switch out the prefix for times 10 to the power something. So we switch out giga with times 10 to the power 9. We switch out mega with times 10 to the power 6. We switch out kilo with times 10 to the power 3. We switch out centi with times 10 to the power negative 2. We switch out milli with times 10 to the power negative 3. We switch out micro with times 10 to the power negative 6. You might not really have come across micro before. Micrometers are the size of things inside living cells, things like the size of the nucleus and cytoplasm and all that really exciting biology stuff. We switch out nano with times 10 to the power negative 9. On the right are some examples. We have mega, kilo and micro. So we switch them out with times 10 to the power 6, times 10 to the power 3, and times 10 to the power negative 6. Don't be worrying about what times 10 to the power something actually means. Just know how to get it into your calculator. But this is why you need to get a scientific calculator early, and actually bring it to class and learn how to use it, so you know how to put times 10 to the power something into it. All calculators are a bit different, and you won't be able to use your phone in the exam. Time must be in seconds, and small measures of time are just as we did before. So 10 milliseconds would be 10 times 10 to the power negative 3 seconds. 4 microseconds would be 4 times 10 to the power negative 6 seconds. Big measures of time are different but still not hard. To get minutes into seconds, multiply by 60. So 3 minutes is 3 times 60, which equals 180 seconds. 25 minutes is 25 times 60, which equals 1,500 seconds. To get a number from hours into seconds, you need to times by 60, to get down into minutes, then times by 60 again, to get down to seconds. So 5 hours is 5 times 60 times 60, which equals 18,000 seconds. Maths. The sooner you can get the hang of this, the easier physics will straight away become. You can do this. I don't think anyone has any difficulty when you don't have to rearrange stuff. So here, if a person runs at 3 meters per second for 10 minutes, and we are asked for the distance traveled, the first thing we do, as ever, is the shopping list. We write out in symbol form what we are given, and what we are trying to find. So speed equals 3 meters per second, time is 10 minutes, but we need to convert that into seconds, and D is question mark because that is what we are trying to find. The shopping list is step 1. Step 2 is to look at the formula sheet and copy out a likely-looking formula exactly as it appears on the formula sheet. Likely-looking means a formula which contains the symbols in your shopping list. Don't do the formula from memory, even if you think you know it. If you don't write out the formula exactly how it is given on the formula sheet, you won't get the formula mark. The third step is to stick the numbers in. Again, the shopping list really helps here. The fourth and final step is to do the maths, and remember the units at the end. As I say, I don't think this kind of calculation, where you follow the formula exactly as it is given on the formula sheet, causes any problems. But what people can find difficult is if there has to be some shuffling of numbers around to solve the calculation. I'm going to show you two methods of doing this. You can then pick whichever seems simpler to you. Or you might have your own way which is different. And that is totally fine too. If a cat runs 20 meters in 5 seconds, and we want to calculate its speed, we start out by doing the shopping list and writing out the formula and putting the numbers in as usual. The first method is more of an algebra method. We want, in this case, v by itself. So we grab the 5 and move it to the other side. But if we change side, we change sign. Now the 5 was being multiplied by v. The opposite of times is divide. So when we change the side the 5 is on, by grabbing it and moving it across, the multiply becomes divide, and so the 5 goes underneath. Carrying on, the answer comes out as 4 meters per second. The second method is maybe a bit more popular at National 5. It uses a triangle. So this is the same question. So we've got the same shopping list, the same formula copied out, and the numbers stuck in just like before. And you maybe think, what next? Well, draw a wee triangle and cover up what you are trying to find. In this case, we cover up v, and the triangle tells us that the next line of working is going to be 20 over, or divided by, 5, leading to the right answer. Please don't ever write the formula as d equals st in physics. That's not how it appears on the formula sheet. So you won't get the formula mark. I know they tell you to do it like that in maths, but this isn't maths. Do the physics version of the formula in physics, and the maths version of the formula in maths. Here's the final example, which we'll firstly do by the algebra way. A washing machine drum spins round with a frequency of 30 Hz. Calculate the number of rotations it will complete in a time of 40 seconds. Step 1, as ever, is the shopping list. F equals 30 Hz, N equals question mark, and T equals 40 seconds. The likely-looking formula we find on the formula sheet is F equals N over T, so we copy that out. Numbers go in next. We want N by itself, so we grab the 40 and pull it over to the other side. But when we change side, we must change sign. The 40 was underneath the N, so now must be brought back up, to be next to, in other words multiplied by the 30, when it's moved to the other side. Then we just carry on and get to the answer. This is the same question, but this time we will use the triangle method. The triangle method starts off with the shopping list, copying out the formula, and putting the numbers in, just as normal. But then we think, how do we solve that? Draw a quick triangle. Cover up what you are trying to find. In this case, we are covering up N. By covering up N, we can see the next line of working is going to be the F number multiplied by the T number. And then, the rest becomes easy. Finally, how do you draw these formula triangles? What letter goes where, in the triangle? The formula sheet only gives formulas, not triangles. It's actually quite simple. If the equation is all on one line, for example, d equals vt, then it's the first letter that goes at the top of the triangle. So in this case, d. If the equation is a fraction, for example, f equals n over t, then it's the second letter that goes at the top of the triangle. So in this case, n.